Thank you for downloading this Hanson Math video. I hope you enjoy this lesson on exponents and an introduction to monomials. Here we go. The first thing I'd like to go through is looking at a pattern of exponential powers. I've chosen to use 4 as the base, starting with 3 as an exponent and descending all the way down to -3. Now, to illustrate this pattern, I could have used any number, but 4 is as good as any, and I figured we'd start at 3 and go 2, 1, 0, -1, -2, -3 as far as the exponential powers. So, taking it from the top here, we have 4 to the third power, which really means 4 times itself, and working that out, 4 times 4 is 16, times 4 again is 64. 4 to the second power is just 2 multiplications, 4 times 4, which is just 16. 4 to the first power, of course, is just 4. Okay, now this is a tough one right here. 4 to the 0 power. Students forget what that is. They want to say 0. Okay, it's not so, and let's figure out why. If we look at this as a pattern, to go from 64 down to 16 was dividing by 4. 16 down to 4 was dividing by 4 again. So as you descend down this list, you're dividing by 4 every time. So the pattern will continue as long as you keep dropping the exponent by 1. So if we had 4 to the first and now 4 to the 0, we have to take that preceding answer of 4 and divide it by 4 again. Well, anything divided by itself will always be 1. Okay? So anything to the 0 power is 1. That's a property because it comes from a number divided by itself. Now, moving on into the negative powers, which we're going to talk a lot about, you're going to continue with this division by 4, since 4 was our base. So we last left off with 1, so now we're going to have 1 divided by 4, which is 1/4. 4 to the -2 tells you to divide by 4 again, so it's really like 1 divided by 4 divided by 4. That's 1 divided by 4 squared, which is 1/16. And then 4 to the -3 is dividing by 4 again, which is 1/4 to the third power, which is 1/64. So a big takeaway from this is the following. 4 to the third was 64. 4 to the -3rd was 1/64. 4 squared, 16. 4 to the -2nd, 1/16. 4 to the first, 4. 4 to the -1st, 1/4. Okay? The negative power has nothing to do with a negative sign or value. When you're dealing with exponents, a negative power indicates you're taking a reciprocal. Okay? So reciprocal, which is like a flip, that's the instruction when you have a negative power, or as we say, exponent. Okay? That's going to be really important here. The reciprocal is taken when you are given a negative exponent. So let's look at a few examples here. If I gave you, let's say, 3/4, okay, sorry about that. If I give you 3/4 raised to the -1 power, that means to take the reciprocal or the flip, so you end up with 4/3. If we had 2x over y and you're told to take the reciprocal, which is the -1 power, you'd have y over 2x. Okay? So the reciprocal is just a flip, but this is really important to know so that when you're doing multiplication and especially division of monomials, you'll know what you're doing. Okay, moving along. Let's use some examples here with negative exponents that you'll encounter. And we're going to use the information we just discussed. When you see a negative exponent, that's what I'm talking about, right here and right here, that's your instruction to take the reciprocal. So again, this will help too. any whole value can be put under 1 as a fraction because that means you're counting it as a whole. So the negative, again, just tells you to take the reciprocal. So instead of a to the negative fourth, you have 1 over a to the fourth times, instead of b to the negative second, you have 1 over b to the second. Now when you multiply straight across, you have just the 1 on top, and on the bottom you have a to the fourth b squared. In the next example, again, if you want to put them over 1, that's fine. C to the third power, this already is a positive power, so it's fine. There's nothing to do with it. It remains c cubed. But now b to the negative eighth becomes 1 over b to the eighth. And when you simplify this, you have your c cubed on top and your b to the eighth in the denominator. Okay? So that's some basics working with negative exponents. Now we'll do a couple slightly more involved examples. A really good way to work on this, again, since the negative exponent is the instruction to take a reciprocal, if a negative power is on the bottom, it's going to flip to the top. Okay? So I'm going to start here with my fraction bar. 2w is in the numerator. That's going to remain in the numerator. X to the negative third is in the denominator, but that negative power instructs you to take the reciprocal, so it flips from the bottom to the top. So now x to the positive third goes on top. Y to the ninth is in the denominator, and the exponent is positive, so it stays in the denominator. Okay, this takes a while to get a hang of, but you'll get used to using the reciprocal. Now, in the next example, we have b to the negative fourth. Again, that negative power is the instruction to take the reciprocal, so that moves to the bottom as b to the fourth. And it doesn't mean there's nothing on top. On top you have a 1. And on the bottom, a to the third remains because its exponent was positive. Okay, again, you can always rewind if you need more explanation. Just a really quick introduction here into monomials. A monomial is just one term. Okay, all of these are examples of monomials here. 5x, negative a, 17, x cubed, 1/2 x to the fourth y squared. There's no addition or subtraction between the constants or variables. They're just one term. Now, it's important to note what monomials cannot be. You cannot have the variable contain exponents that are not positive or whole. So, in other words, it means that the variables cannot have negative or fractional powers on them. So, this guy right here is not classically considered a monomial. You would think it would be looking at it, but again, that 1 over n squared indicates reciprocal. So, it's the same as n to the negative 2 power. Now, that's not a monomial because of the negative power. And you may remember that the square root of something is the same as raised to the power of half. That's not a monomial, again, because you have a fractional power. So one quick compare and contrast examples of monomials. Well, you could have 8x, 1/2 ab. Again, the 1/2 is okay if it's in the coefficient. It just cannot be in the powers. And we could have x squared, y to the 8th, z. Those are all good. Now, not monomials, again, that would be if you have fractional or negative exponents. So you can't have a to the negative third. You can't have the cube root of xy. You can't have xy to the 3/8 power. Okay? None of those are acceptable for the reasons I've outlined. Now, it doesn't mean you can't work with them. You will, in fact, work with them a lot. They're just not considered a monomial as written. Okay, just a little bit more review here before we wrap up this video. Constants. Constant just refers to a plain number. They are monomials that contain no variable. So constants would be 7, negative 15, negative 1, 2/3. Okay? Constants are just basically plain numbers, not variables. Now, Constants take on the effect of a coefficient if they come in front of a variable here. So if you want to hit pause and try these on your own, feel free. We're going to go through the coefficient of each of these. Again, it's the constant that precedes the variable. So in 5x, the constant is 5. In negative a, the constant is negative 1 because there's only one a here, not 2 or 3, just 1. The constant in 3x cubed is 3. And the constant in 1/2 x to the 4th y squared is just 1/2. All right. The degree of a monomial, sometimes you hear that terminology. The degree is the sum of the exponents. So x to the 4th y squared is a monomial because it's one term. And we say it has a degree of 6 because if you add the exponential powers 4 and 2, you get 6. So how do you determine the degree? You simply add all of the exponents of that term. So here we go again if you want to hit pause and try it on your own. If not, we will keep on trucking. 2x squared y to the 5th, if you add the 2 and the 5, this has a degree of 7. Here we have an a, y, and a z all raised to the 3rd power. 3, 6, 9, that's a degree of 9. And jgh, you might be misled on this. Keep in mind that the variables, if you do not see an exponent, that's being raised to the power of 1. So g to the 1st, j to the 1st, h to the 1st, that's a total of 3. I want to thank you for watching this installment of Hansen Math videos. The next one is more in-depth work with multiplying and dividing monomials. Thank you so much and have a great day.